Welcome to No Password Required. I'm your host, Jack Clabby, a cybersecurity attorney at Carlton Fields, PA. With me, as always, is...
I'm Kayley Melton, the Executive Director of Operations for the Cognitive Security Institute and, of course, the Bob Ross of InfoSec.
Kayley, we just finished a great conversation with Steve Orrin. Steve is the Federal Chief Technologist at Intel Corporation. So he has a very cool, very big job. But what stood out to you the most from this conversation?
It was honestly really hard to choose, but I'm going to go with the new information that IoT is officially called the Edge, and I can't help but wonder how U2's The Edge feels sharing his namesake with that.
Yeah, I'm sure he thinks that it's named after him, which it very well may be.
Of course.
Very well may be. But I think it was a great conversation. We'll get right to it. But I love this idea of putting together teams that are diverse in a number of ways, including old and young, right? Because there's a lot in the industry about young is best because it's most up to date. But there's also, we require ridiculous amounts of experience for every job, which can only be in a person who's older. And so Steve shares a lot about his experiences putting together teams that look diverse in a whole lot of ways. So you've heard a little bit about what Kayley and me took away from this discussion, but let's hear what Steve has to say.
Welcome to No Password Required, a podcast dedicated to showcasing the top personalities in the world of cybersecurity.
Welcome. Our guest is Steve Orrin. Steve, welcome to the No Password Required podcast.
Thanks for having me today.
Steve, tell us a little bit about what you do now at Intel, like what your job is and what a day-to-day your kind of experiences are.
So my job at Intel, and I've been at Intel now about 21 years, I'm currently the federal CTO. What that really means is my job is to help the U.S. government adopt technologies coming from the commercial side of Intel, as well as understand their requirements and how we can customize our capabilities to meet their mission needs, communicate those requirements back to the business units that are building the chips and the various components so that we can better build our future roadmaps to meet those future government needs, and work with the broader ecosystem, so the defense industrial base, the OEMs, the cloud providers, to make sure that they're providing the right technology for mission for the enterprise. And that can cover everything from AI to cybersecurity, which is my background, high-performance computing, to the edge. So it provides a very wide range of capabilities. That's sort of what makes it fun and interesting, is that every day could be a new challenge. But a lot of my role is sort of the collaborative, working with our government customers, working with the business units, helping be a translation function, if you will, between the two. And then oftentimes doing some really cool innovations to get the government customer the capabilities they need that isn't available today in commercial.
And on a day-to-day basis, I mean, are there agencies that you work with in the federal government more than others? Like, who are the main customers you might work with?
Well, you typically work with the ones that have the most unique mission. And so a lot of times that's DoD and the intelligence community, law enforcement, Homeland Security. They're the ones that have some of the scale and some of the unique challenges that sort of standard commercial IT or commercial cloud offerings won't satisfy. That being said, the government has a scale that you often don't find even in commercial spaces. So, the VA is a really good example. The Veterans Administration, it's a hospital organization, it's an insurance company. So they have a lot of the same applications that you'd find in the private sector, just at a much larger scale, with the addition of additional security requirements, whether that be things like cloud security for FedRAMP or things that have to be deployed on bases. So you get some unique requirements, but you get a really interesting scale that then allows us to sort of figure out how would we scale that capability of those applications or get better performance. And then that helps, the commercial and private sector, because they get the benefit of us building for those large scale enterprises and be able to take advantage of that. So that bidirectional side of it, of looking at these use cases and the immense scale or the distributed nature of the government allows us to build better products, honestly, even for the private sector that will have those same problems, maybe not today.
I mean, Steve, given the impact on what you do, yeah, I'd love to hear how you got to here.
Well, that's a really good question. So it goes back. I started back in the mid 90s doing security in startups. I had the wonderful opportunity back in the mid 90s to do my first startup right out of college, solving a particular problem at the time, which was desktop and file encryption, and then soon after email encryption. And then after that startup, did another one I started from scratch that did mainframe security. So switched to the other side of the equation, if you will, from the edge where, PCs and laptops eventually to mainframes and backend systems, and really trying to solve a hard problem of how do we secure and enable those legacy platforms to communicate to clients and to the web. Then in the 2000s, I did a security startup that I joined that was sort of just getting off the ground, and we created the web security market. So I've had this opportunity to be in some really market-changing places. And around 2005, the XML security company I was working for got acquired by Intel. And at the time, I was thinking, okay, I'll serve my 6-month sentence and then go do another startup because that's what I was used to. And the head of the software group at the time, Renee James, came to me and said, well, Steve, what do you want to be at Intel? And I said, well, you have a CTO and he's pretty good, but that's really what I enjoy doing. And she talked about this new idea she had come up with, which was called pathfinding. And the idea was, Intel has a labs that basically looks 5 to 10 years out on the horizon. So they're thinking some of the pure research or forward thinking 5, 10 years out, what will be. And the product units have a 2-year cadence. Basically, once something's researched and it's ready to go, it takes about 2 years to sort of lay the silicon and build the next version that keeps coming out. But there was this middle window between the 2 to 5 year window that wasn't really being addressed from an innovation perspective. What could you do with either existing hardware or hardware that's about to come out? What novel things could you do in software or in firmware that could be very innovative? And so she was creating a new team called a pathfinding team to be that bridge, and wanted to know if I wanted to lead the security pathfinding for Intel. And I said, so I get to basically play CTO with Intel's budget and no more VCs. I think I could do that. So I did that for about 10 years, driving innovations around first virtualization, security, cloud security, our first cloud security architecture back when no one knew how to spell cloud, innovations that led to using hardware to help inform anti-malware products. So leveraging your hardware platform to give you insights that you couldn't get from your OS. And that led to things, integrations with McAfee and other companies. And so really a lot of game-changing capabilities without having to lay new silicon, basically software, firmware, and ecosystem enabling. And throughout my career, because security has always been top of mind and one of the key challenges in government, I've always worked with government agencies through my startups and even early at Intel, helping them to adopt or provide the right requirements for what they needed to secure their systems to the government level. And so when Intel was forming their government division, they realized they needed a technology leader. And so they offered me the opportunity to come over to the federal team and lead the technology practice for Intel. And so back in 2013, I took the leap, moved back to the East Coast because I'm an East Coaster, but I keep escaping to California. So I moved back to the East Coast and have been doing technology innovations with the federal government ever since.
Steve, where were you doing when you were doing like the mid-90s startup scene, right? Working on encrypted email. Were you East Coast or West Coast at that time?
New Jersey. So I was, did my first 2 startups were in Northern Jersey. And it was actually really a good place to be because you think about who are the big customers. You had financial services, that was in New York. You had pharmaceutical and biotech, that was Jersey. You had healthcare and insurance, that was Connecticut. And then federal government was just a train ride down to DC. So you had all the customers here. So everyone thinks about the West Coast as being the hub, but there was a lot of really cool things happening here on the East Coast from Boston to DC. And so being in New Jersey was a really good place to be at the time.
I love that idea of, I'm a Monmouth County, New Jersey guy. And Middlesex, I know exactly what you're talking about. Yep. And pharmaceuticals are there too, and a lot of higher education. So you've got a great basis for it. But was it the mid-90s mid-90s security startup that we think of? Like, were there ping pong tables with pizza boxes and skateboards involved in this. What was the scene a little bit like, Steve?
So it's interesting. It wasn't that scene, although we tried to create our own little thing. So while we didn't have the ping pong tables, we did have the, like at 8:00, the pizza would be delivered. And one of the things I really enjoyed about my, in the first and second startups is at 8:00, the entire company, whether you were a developer, a marketing person, a salesperson, the CEO, we all got on and did some form of death match. It could be a Quake death match. It could be any one of the current video games out there. The whole team, we hosted a server and everyone would play for a good half hour to an hour and then go back to work. Because let's face it, we were all startups. Yeah. One of the other interesting things that we had, and I noticed, is that while in the West Coast, you had a lot of this young startups with, a lot of young kids, and we had the same thing in our environment, but we also had access to a lot of people who'd been software and developers for many years. So at my second company, one of the interesting dynamics is we had these young crypto engineers. There were some fresh out of college or fresh out of grad school. And in the same company, in the same team, we had people who had been working for IBM and SAS and the banks for 20, 30 years already. So they're already into the end of their careers working together. So we had that really interesting dynamic of the seasoned professional, we used to call them the gray hairs. I think I'm there now. And the young kids working together to solve really interesting problems. And that dynamic actually was really fascinating to watch as the older developers learned these new techniques and new technologies like Python and scripting. And these young developers got an opportunity to understand what change control management was and how do you build reliable computing that has to be up for 17 years plus without ever going down. And so there was a really good dynamic that we had at Lockstar at the time because of that.
Well, I love that idea of like, you're not going to have an ageism issue, right? You're not going to have people who are locked out because they're too young. You're not going to have people who are looked at as being not innovative because they happen to be older, right? You're going to just find the right people. How did that team come together? Was it word of mouth? Were you meeting on message boards? Like how did you pull it together?
So a lot of it was sort of the networks of myself and our other founders and our local VCs, reaching out to people we knew, forums. In the case of, a lot of the ones that came out of the financial services, people were starting to think, well, how am I going to get into the startup craze? And it allowed them to do it without moving west. And so we actually were very attractive. And because at the time we were doing, some very interesting things, a lot of them were looking for something that was more interesting than, fixing COBOL programs. And so we got, we had a really strong team of developers. And it's really just that local word of mouth. We had some really good recruiters who knew the different organizations out there. But also we went to conferences. I spoke at more mainframe conferences than you'd never have heard of. And you would get interest because, hey, you're doing something really interesting. As IBM once said about us, we're making mainframe sexy again at the time.
That's a quote you print and put up on the wall.
Exactly.
Yeah, absolutely. A t-shirt at least.
Exactly.
So you've said you're a technologist first and foremost. I mean, technology is literally in your title right now. When did you realize that technology was going to be your life's work?
So it's a great question. And it actually wasn't originally the plan. So back in '89, when I sort of had to make a decision of what I want to be when I grow up, there wasn't really a career in security or technology for that matter. My two loves growing up were biology and hacking. And those were the two things. You really couldn't, pay the bills with a hacking degree. There wasn't a hacking degree. So I went the bio route in college. I did research biology, had a couple of years of graduate research in biochemistry, molecular biology. And that was going to be the plan. I was going to do an MD, PhD, and probably still be in school today if you play that out. And it just so happened that in '95, I had a grant that ran out that I was on. So I was about to go do a new grant proposal. Was thinking about, I had a year before starting med school, and a friend of a friend basically came to me and said, hey, this technology stuff, the security stuff, you were a hacker as a kid. There's a guy who's got some money, who wants to do something in this internet security domain. Why don't you help him out? And I'm thinking, I could use some money to pay for med school. Let me do this. This will be a good use of time. I'll make a little money, and then I can, help defray the costs. And so I started that with him back in March of '95, got the company off the ground by May. By September, I was full bore in love. It was just an exciting time to be doing that. And by September, I said, this is going to be my life. And it took about 2 more years before my parents thought I hadn't gone crazy, because they're like, "What, you're throwing away your medical career? What's going on here?" So it took a while to get the parental units to come along for the ride. But like I said, by September of 95, I was all in, because it was exciting. And really at the core, both of what I was looking at to do in biology and what I was doing in the technology, it's about, being presented with the interesting problems and trying to solve interesting problems in interesting ways. That's what gets me up in the morning, is how do you solve those hard problems? Whether it's trying to find out what the cause of a certain disease is at the molecular level, which is where I was doing my research in, or, what makes a system fall apart when a hacker takes it to town? How could I prevent a hacker from doing certain kinds of things? And so those kind of inner problems is really what gets me up and makes it all exciting.
Yeah. Do you feel like your current position at Intel now scratches that itch the most out of the roles that you've held?
So that's a really good question. I would say that it does, and in an interesting way. So obviously, when I was doing startups, every day you're presented with a new challenge, and you basically burn the midnight oil and candles at both ends all the time, solving every challenge that gets thrown at you. What I find at Intel is sort of 2 things. One, you get some really interesting challenges, but it's really the scale that is amazing. And so when you're presented with, how do I solve this problem? It's not, how do I solve for this one customer? How do I solve this problem for 40 million customers or for 50,000 laptops? So the scale presents a really interesting problem. And then the universality of that problem. So if this problem is a problem for this kind of device, let's say you have a problem for an airframe over here. Well, is there a similar problem for a ship or for a vehicle? And so I think the scale and the fact that, we joke about, Intel Inside really does mean Intel Inside. We are in the laptops, we're in the network, we're in the cloud, in the servers, in the planes, trains, and automobiles. All of those things, the MRI machines, they all have Intel chips, which means when we look at a problem or a data flow or an application, we get to see it at all parts of its life cycle. And so the challenges we get, I don't get as many per day, thankfully, because it wears you out after a while. But the challenges you get are really meaty challenges. And when you come up with a solution, one of the things I've told some people is one of the first projects I worked on, the output of that went on to 40 million laptops at the time, which is back in the late 2000s. So 40 million laptops got an innovation that I helped create. That type of scale, even in my most successful startup, that wasn't even possible.
Yeah, that's incredible.
You mentioned too MRI machines and ships and things. Like 5 years ago, Internet of Things was sort of a hot topic, like AI is today. But it's not like the Internet of Things went away, right? It's still here, but we just kind of forget about it. Are you working with solutions that touch not just laptops and mainframes, but you're dealing with the connected ice machine and things like that?
Absolutely. So the edge, as we call the edge, IoT is now the edge, because the world is framed from AI. And what are those IoT things? They're the sensors, the data generators, and the actuators. So either they're providing data to your AI and machine learning, or they're the thing responding to the decision. Car, don't run into tree. Those are your IoT of today. And it could be a thermostat. It could be a fire suppression system. It could be an MRI. It could be any one of a number of devices. So the edge, or the IoT, is a fundamental part of the AI story that often gets forgotten because everyone's focused on the training and the inferencing. But where is that happening? Where is the data coming from? It's coming from an edge sensor. What are you trying to do? Well, I need to get the plane to move left. So the IoT is a critical part. And what we're seeing as an interesting trend just on the AI side is that, everyone for the last 5 years has been focusing on the large and big capital L large language models and large data sets and billions and trillions of parameters. But the ones that are actually generating value are oftentimes the smaller scale that are deployed at the edge. I send something, I make a decision, I do something, all in that loop without ever talking back to some cloud or waiting for a response. And we take for granted a lot of times, if you have an autonomous car or a semi-autonomous car or even a lane correction car, it's not talking to the cloud to tell you not to turn right into that car next to you. It's making a decision in real time based on sensor data it's collecting, an inference it's making, and then it's saying, it's pulling the steering wheel the other direction to keep you from getting into a wreck. That is a real-time implementation of AI at the edge. It happens every day. People don't even realize it, that it's ongoing. So we are absolutely involved in a lot of those IoT use cases. One of the, you pick on the MRI, one of the projects we worked on at Intel was being able to get better performance out of those machines by building in the computing and the machine learning so that you could turn what could be, hours of time in an MRI machine to do a full body scan down to minutes. And for one of the big challenges that they took on was for children. Children can't sit still. I mean, mine can't sit still for 10 seconds, but imagine for several hours, and being able to drive that down to a few minutes to be able to get a scan is life-changing because you can get results quickly and then give the doctor the information they need in a timely fashion without having to rerun the scan.
Right? You can get more access to the machine, right?
Exactly.
So given the scale that you see things at, Steve, and the position you're at, I mean, are there lessons or biggest blind spots that you've identified that companies can be aware of? I mean, just because the vertical of what you're seeing is so much, right? What are some of the blind spots that you think companies should be aware of for cybersecurity or building secret products?
From a cybersecurity perspective, I think there's two, and they're on opposite ends of the spectrum. So we'll start with one that gets brought up often, but doesn't necessarily get the same credence because it's less sexy, and that is the people side of the camp, the organization, the culture. One of the things that I've seen as often as blind spots is making sure that the security people, the people who understand the security challenges, the hacker mentality, they understand the compliance requirements, are involved in projects from the get-go. Most projects, if you look at the vast majority of them, security is either mid or late stage. It's, well, we built this thing, we're going to go solve it. Okay, check us out, make sure we didn't do anything wrong. And that's the wrong time to be asking that question because number one, you're already up against the deadline. You haven't incorporated their feedback before, so they're going to look at it and say, well, of course you've missed all the things. And then you have to go back and redesign, or you just skip them altogether and you end up non-compliance or hacked. One of the big blind spots is getting those people that they actually can provide real value at the design and requirements definition phase. And the successful organizations we have seen have incorporated security professionals into those early stages, get better products outcome because they think about things from a different perspective. And this goes to something I learned early in my career, is to surround yourself not only with people smarter than you, but a diversity of thought. So people with different backgrounds or different job roles, providing the insights throughout the whole process. And so we pick on cybersecurity based on your question, but getting the legal and compliance people, getting the sales people, the people who are going to ultimately have to sell your product to those customers, having them involved early in the life cycle always reduces the time for fixing things later, get you out the door, and get you better products. So one is the cultural organizational structure. Again, less sexy because it's not cool technology, but the investment is way outweighs any cost of bringing those people in early.
Right, you're already paying for those people.
Exactly.
Just putting them in a little bit earlier than you normally would.
Exactly. And having them, and also one of the really cool things you get is that feeling of contribution. So if the security people involved in the design requirements, when this shows up on their door to get checked, they're like, well, not only have I put my input in, so I'm already sort of in your camp, but they don't have to start figuring out what it does. They were there for the decisions. They were there for the reasons. You don't have to explain why you made a decision. They were there for that. And so it makes the whole process much more streamlined. So that's one of the big blind spots. The other is cybersecurity in general. Most organizations, whether it be a new web application, a desktop app, an AI, they're not thinking about security as they're building the product. And so they're not building in the necessary controls, the necessary hook points, the necessary checks and balances that you would need, or the artifacts that you want to be able to present to make a security case later on.
Yeah.
And so, pick on the AI pipeline, for instance. A lot of times people think, I need to protect the AI now that I've done the training and I'm all done. I'm going to go deploy it. How do I secure it? And that really is hard because you don't know what data went in there. So is the data been poisoned? Is the data biased? What governance controls did you put in on the tuning and the parameterization? What about the federated learning? None of that has been addressed until way too late in the game. And so building security technologies in and controls all the way up. And that's why you'll see a lot of the AI frameworks talk about governance. That's the word we use. But governance translates to security, compliance, and manageability. And so having that built in from the get-go allows you to then be more successful and to be compliant when you get out the other end. And then it doesn't end with deployment. So I secure it, I put it out there, I'm good. Well, no, AI is an evolving thing. It's actually different than many of the applications we've ever built before. Because we build applications, I build a version. The only time it gets updated is when I do an update.
It'll work.
It's constantly learning. It's constantly changing. So how do I monitor that AI going forward to make sure it's not being, it's not hallucinating, it's not forgetting, it's not being poisoned, or it's just not failing in places where I didn't know about biases that were introduced. And so monitoring and securing the AI post-deployment with continuous monitoring concepts. And again, these are not new. Zero trust has been around, but we have to apply it to AI like we would to any other platform or application.
You don't just send another AI to keep an eye on it. You got to.
Well, actually, that's funny you mentioned that. There are examples of where you would use the AI to help test. So automating the process. How do I test for hallucination? Well, you can create a data set that's sort of clean from the one you trained on, but from the same source, and create an LLM to actually try to see what these are. So you can have what I call LLM on LLM violence, but the idea is that you can use a separate LLM to keep monitoring your AI and make sure that it's at least stated within a certain parameter. So our techniques of using AI to help your AI, but you also want to have a process. It's really the process that you want to implement to drive those, whether it's an LLM or some other technology.
So you've talked about surrounding yourself with people who are smarter than you. How do you spot and nurture that kind of talent in the wild?
So it's a really good question. And it goes back to, I had the unique opportunity early in my career to hear from and meet Jim Collins from Good to Great and Built to Last. And he talks about sort of surrounding yourself, getting the right people on the bus and listening to them was the term I used in the book, but it's really about surrounding yourself with smart people. And part of that is when you find them, you nurture them, you grab onto them, even if they're not in your group, you still maintain that relationship. But it's also as part of the hiring practice. I want to surround myself with experts in their domain. I want, on my team, I have a couple experts in AI, I have experts in threat intelligence and cybersecurity, experts in firmware, experts in networking. These are all incredibly smart people in their domain. And some of them are early in their career, some of them are later in their career. You want all that diversity of background. Mm-hmm. And the key thing is you give them really interesting projects and enough rope to go off and do fun things. You don't micromanage really smart people, but you give, I think of it less as management, more as direction. You give them a direction, say, we want to get here. Tell us how we get there and go try stuff. And the payback is huge. I'll give you a great example. This goes back a few years. I have 2 AI people on my team, one of them directly on my team, and one of them is in another division who works on government programs with us. One is an expert in performance optimizations for AI and AI models. The other is an expert in sort of next generation AI training and AI techniques. Both of them came to me and said, hey, there's this really cool thing going on. They came to me at different times, but within the same week of this generative thing that's going on that you got to learn about it. This general transformations, and it's really cool stuff. And here's the math, but forget the math. This is what you could do with it. Fast forward, within 6 months, ChatGPT came out. So they were my bell cows. They told me about this technology that was coming. They were already seeing the research papers, seeing some of the innovations out there, and they were able to come and explain enough of it to me. So when ChatGPT became this huge thing, we were ready. We already understood it, and we could be then much more prepared for the myriad of questions came in. And so what does Intel think about LLMs? Well, we had a story because we had these smart people thinking and looking at these things. And that's really what some of these really smart SMEs can do is they see out there and they can bring that to you. The other is when you get them in the room with each other and you start seeing the interplay. So you have the AI person and it was working with one of my wireless people, and we came up with a really cool idea of how to use AI to better predict path prediction through a cellular system. So if I want to be able to know what's the best quality of service I can give to, a general in the fields, because he or she wants better service than everyone else, part of it is understanding what's the route they're going to take and using an AI to better predict that. We individually, neither one of them probably would have come up with that because they didn't have the tool set, but putting them together just we didn't task them with this. They just sort of came up with it as, hey, this is a really good, interesting idea. What do you think? And we said, well, let's go take it to the customer. And so that's that interplay of the diversity of thought that really drives a lot of the innovations.
Steve, just one thing, because you've done so many cool things, but you're also up to speed on kind of what cutting edge is. I mean, if you were to give some advice to a young person starting out a career, let's say in cybersecurity or security generally, what opportunities would you be excited to chase, or would you suggest that they get into?
So the advice I give to young up-and-coming people or people who are looking for a career change, there's sort of two things. One is get the technology and play with it. So I suggest, download Kali Linux, not onto your corporate laptop, onto a personal one, and try to break things. Play with the technology, understand how things fall apart. And so from a cybersecurity perspective, one of the things that one of my early mentors taught me, which was Bruce Schneier, is you can't build a crypto system unless you understand how to break it. And so you first have to understand how to break crypto systems that exist before you can really build a secure one. And it holds true with all of security. Before you can be a defender, you really have to understand how an attacker will come at you. Because if you lock your front door with 100 bolt locks and they come through the back window, then you haven't done anything. That's really, if you think like a hacker, think like a cybersecurity person, you're thinking about all the ways they can get in. And that's really, the advice I give is understand that mentality. And the way to do that is to try it, to play with it. At various different security conferences, they'll have hackathons, and they have a hardware hacking village over at the at DEF CON, for instance, where you can get a little board that's got various different components and try the games to see if you can get in. And you have like 24 hours to do the job. And it's a fun way of honing your skills and getting your hands dirty. And that is one thing that I think a lot of cybersecurity people sort of take for granted later in life, but that they did as a kid, is sort of playing with the technology. The other is you don't always have to have the game-changing next whiz-bang thing. Doing an innovation on something that's already making it faster, better, or more secure is equally important, and sometimes a bigger deal. You look at some of the biggest companies over in cybersecurity, and you can pick on the early firewalls. Check Point wasn't the best firewall at the time. There were much more secure and tried and true firewalls, but they were the easiest to deploy at scale. And they won in their early days. And you look at Palo Alto and FireEye and the others today, what makes them successful is their ease of adoption and ease of scale and ease of integration. Nothing to do with security, but it's understanding, how do I take this security thing and make it work for a customer? And the last thing I would say, and it goes to that customer part, talk to your customers, hear what their problems are. Oftentimes we forget that the problem that your customer is having is really what they're going to spend money to solve. You want to help them, but you need to understand what they're really trying to solve, not just what you hear from the Gartners or from the analysts and so forth. Talk to your customers, listen to them. Don't sell to them. Let them tell you what's driving them batty this week, and see if there's something you can innovate there.
That's you, Steve. Thank you. Let's take a short break now, and when we return, we'll have Steve go through our lifestyle polygraph. So stay with us.
You're listening to the No Password Required podcast. We cover cybersecurity and a lot of other stuff.
Welcome back. As many of you know, the lifestyle polygraph is a test used by the federal government to determine if a person is worthy of learning our nation's most important secrets. Here, we use this technique for only slightly lower stakes to determine whether our guest can join our fantasy cybersecurity squad. Steve, are you ready for the lifestyle polygraph?
I'm ready.
All right. Question 1. If Intel gave you an unlimited budget to launch any crazy project tomorrow, no strings attached, what would you do?
That's a great question. Right now, I think the thing I would go after is products and technologies in what we call the counter AI space. There's a lot of innovation going on in AI, but there's a lot going on behind the scenes on how do you trick AI and how do you tell if you're being tricked. The one we're most familiar with is deep fakes, but that's really, a social media side of the camp. There's a whole lot of research into ways to trick, computer vision and other kinds of recognition algorithms. I think that's an area that if we start investing in today, with unlimited budget would be great. We could build the techniques that we're going to need, and really we need today, but we're definitely going to need a couple of years to help our AIs better know and help us know whether we're being tricked. I think that's the biggest problem, is the technology has gotten so far where we really can't tell sometimes if that video or that audio or that data is real or generated. And so having techniques at our disposal to detect those AI techniques is going to be crucial. And it's an area that today, you're not going to make $1 billion from it today. But I think in the future, everyone's going to be asking the question, is this video real? Is this document that looks like it's real? Is this news report real? How much of it is real? And those are questions that it's very hard to answer. So I think the counter AI or the AI deception techniques and detection is really going to be a game changer. So that's where I would go do some really cool things. And it's exciting technology.
I like that idea of, counter AI as a concept, right? It's like espionage when it was invented, right? Yeah. It's been around for a while, but counter espionage then came to be the cool thing to do. I think the other nice thing about counter AI as like a concept would be, it would be sexy and people would want to work on that team, right? You have no problem recruiting for a team like that.
Yeah. And of course, it becomes a cat and mouse game because then you have the counter AI and the counter. Mm-hmm. It goes back and forth. So it's going to self-fund itself forever.
It's going to eventually just be robots fighting on the moon. Let's just go get it set up. Yeah. All human conflict will be solved by robots fighting on the moon.
Okay, question 2. You've played at the World Series of Poker. What's the best poker tell you've ever spotted on someone else?
Really good question, Kayley. I think so. Thinking back to the World Series and a couple other instances, everyone tries to hide their tells. But one thing that is oftentimes is when people hesitate before they start playing with their chips, because they want to play with their chips to sort of give the confidence. Oh, I've got nothing or something you can't tell. But oftentimes it's right before they go reach for playing with their chips. There's that slight hesitation that you can watch. And that's one of the interesting tells there. It tells them that they want to do that action to try to trick you. So they're being performative in the performance. And that is one of the things you can pick up on.
Steve, does your poker world overlap with your security and technology world, or do you try to keep them separate?
So that's a really good question. I would say, the poker is something I do for fun. I'm never going to do that as a business because then it would stop being fun. But there are certain aspects of playing poker that actually overlap with cybersecurity. One of them is this concept of social engineering. Social engineering, and by the way, phishing scams, all of them are types of social engineering where you're trying to trick somebody into doing something that they're not supposed to do, or to learn from somebody information that they're not readily giving to you. Playing poker, you're looking for those tells, you're looking for their style, you're looking for the patterns in how they play or how they bet. And it's understanding those patterns are very similar to what you do in cybersecurity, looking for those patterns of whether this is legitimate software or illegitimate, or looking for patterns in the actors behind it and understanding that social behavior. So there are really a good parallels between the hacker mentality or social engineering and the playing a good game of poker, because those who play poker regularly know that only a small part of the game is playing the cards of the statistics. It's really you're playing the player. And so, yeah, I have played with hackers and it's fun to do it. But a problem is when you're playing with hackers, everyone's using the same technique against each other. They're all hacking each other's motives, and it gets to be funny. After add some alcohol, and it gets even more fun.
Amazing. So, question 3, sort of related. Here at No Password Required, we're big on both the hacker mindset and the gambler's mindset, and you're clearly an expert in both. So which do you think is more difficult to teach, and who tends to be a quicker study, hackers or gamblers?
So I think it's harder to teach somebody to become a hacker because it's really a different way of thinking. I've learned this throughout my career. A lot of people, when you take an engineer, their whole mindset is, how do I build something? How do I make something? How to make it look the most, the most exquisite, simplest way to get from task A to task B. And they're very much focused on how it works. And so when you have a requirement that says button must, do something, they make that button do something. Where the way a hacker thinks is, what are all the things I can do to cause that button not to work, or to cause the button to do something slightly different? And so it's really changing the way you think about things. In the early days, we used to call it, the anti-tester or the anti-programmer is really what the hacker is. And so part of the challenge is teaching that kind of mentality of way of looking at the world. It's almost like a destructive way of looking at the world. How does this thing work? How does it fall apart? How does it fail? We do see corollaries in others. So reliability engineers have this notion of, you want something to be reliable to 0.9999%. What's the what are all the ways it can fail, all the failure modes. That's similar to the hacker mindset, all the different things. And so some of the early sort of worms and viruses took advantage of functionality that was correct and did, but no one ever thought to, what would I do with 1,000 or 10,000 letter A's and an input field? Right. Well, that was code red. And there you had a massive worm, because no one thought about what you could do if you went beyond what the parameters were. So I would say teaching the hacker mentality, but if you had a gambler and they were a good gambler, you could get them to make that leap, because they're already thinking about, how do I attack the person? How do I trick the person or learn things from the person that aren't normal? So I think you can get a gambler to become a hacker pretty quickly.
This is a bit of an aside, but are engineers good gamblers?
No, they're too analytical. And mathematicians are the worst. They look at the statistics and say, why the heck are you putting money on this? Your odds of winning are terrible. So yeah, engineers and mathematicians hate gambling because it violates their core mentality of like, well, the stats don't match. The probabilities in favor.
Steve, I have three kids, and we've been teaching them poker. They're high school and below, and we have a hacker, an engineer, and a mathematician, and that is exactly how they play with each other. And the mathematician's like, why didn't I win? Why didn't I win? And it was like, well, you didn't stay in the hand. That's why you didn't win,
That's amazing.
It was that's exactly what we're going on with them. I love it. I'm going to start calling them that.
Yeah. That sounds like the start of a joke, really.
Yeah. Engineer and a mathematician walk into a bar. Yeah.
Yes. Okay, question 4. What horror movie villain do you secretly think would make the best cybersecurity professional, and why? And if you had the chance to actually hire them, what role would you put them in?
So that's a really interesting question, because there are lots of horror villains out there. I'm going to actually go with a little old school. I think Pinhead from Hellraiser would be the one. And here's why. Because it's all about the puzzle box. It's all about solving the cube. And you think about what a cybersecurity professional is, it's about puzzles and about cracking the code. So I think, if anyone knows how to crack the code of the cube, it's Pinhead from Hellraiser. If I would hire them, I'd hire them for physical security, because I think they keep all the bad guys out of the building. And you know what he would do with them if they tried to get in?
That's true.
That's right. And they're somewhat uncorruptible, because they're above the normal human pleasures.
Exactly.
They're in such weird as a dead.
You watch the movies, you know it.
Okay, final question. In your office, you've already got quite the collection. I can see behind you that there are some lightsabers. You have the Hellraiser cube and a serious Lovecraft library. So if you could add one dream item to that collection, what would it be and why?
So that is a hard question, because there's a lot of items I'd want to add. My gut reaction would be is like a first edition Call of Cthulhu signed by H.P. Lovecraft. I have several others that are signed by him, but that one would be a cool one. But I think from a coolness factor, I would like a working Le Marchand cube. So the puzzle box that actually worked. I think that doesn't have to call in the Celebites and bring about the end of the world, but one that you could actually interact with and create the different configurations, I think would be pretty awesome.
That's awesome.
That's a great answer. So Jack, what do you think? Does Steve have what it takes to join our fantasy cybersecurity squad?
Absolutely. Steve, we would love to have you join the fantasy cybersecurity squad. We could see you in a chief technology role, or, I don't think we have somebody who has the depth of knowledge of deployment at scale throughout a federal government program. So you would check a lot of boxes for our excellent team that we've been assembling here in the past few months. So,
well, thank you. It's an honor to join.
Steve, if our listeners want to connect with you or follow what you do, how can they see you online?
The best place to find me is on LinkedIn. And so you can find me at LinkedIn/Sorin, Sorrin. If you want to know more about what we're doing at Intel on public, it's intel.com/public sector.
Very cool. Well, that brings us to the end of the show. Thank you for listening. For the entire No Password Required team, I'm Jack Clabby, and we'll talk again soon.
Thanks for listening to the No Password Required podcast. Join us next time for more with your favorite cybersecurity personalities. In the meantime, consider liking, subscribing, and sharing this episode. You can find us on social media at No Password Pod. The show is produced by Cyber Florida, and a special thanks goes out to our friends at Carlton Fields and Reality Shift. For more information, visit our website at cyberflorida.org/pod.